watch it, understand the workflow, and decide if it's of interest to you to learn. So this is the model I'm going to look at. It's just a simple Revit room with but yeah, basically it's just got a few rooms and a spine corridor. So you've got some context there. Right. So let's dive straight into Dynamo and let's get going. Here's CBDM Tools. It comes as a fully sort of packaged interface, along with any other professional sort of plug-in there. I'm going to go straight to Revit Core, and I'm going to go get me the rooms from Revit. And there we go. So I'm sure you'll recognize that as the room that was just being shown in Revit. Obviously I don't want to calculate everything at the same time, so what I do here is just plug in the next node, give it a reference room to look at, and it's picked out that one, but could be that one. Actually, we don't want to do a north-facing one though. No, not a north-facing one. Yeah, back where we started. Okay, then we push forward and say, right, now we need to translate that geometry into a format that our calculation engine Radiance will understand. So plug in the room names, the Revit rooms, our room index. Let's have a little think about it. And what it's done is actually write a file in Radiance. So can sort of hide that now because we've got all the context that we need. Right. Yes. Okay. Now we move on to the Radiance section, and what we need to do is basically clean up that Radiance file, and now we need to start sort of properly saving it in our project folder. So if the project folder doesn't exist, it will make one for you. Where the hell did that go? Come on. Right. Okay, now it's making lots of windows on my other screen. Right, into so I'm just going to stick it just into my just basically into my documents here. Yep. And I'm just going to give it a I don't know, test example. If the folder doesn't exist, it will make it for you. Right. Okay, now we have our Radiance file. Very nice. Right, now I want to see that model, so now it's going to read the model back in, so we know precisely what Radiance is going to be calculating. That's pretty important, so that we don't make things could go wrong and we wouldn't know that's happened. I don't want to see the coloured outlines. It is actually showing you that it's divided by material there, which again is useful for validation. Right, now I've got that, I will want a calculation grid, and what I need to do is basically just give it a reference surface as basically the outline to build the grid around. And I already knew that number 2 is the floor, so I want to build a grid around my floor. I'm going to plug that reference surface in. It needs the Radiance file address, and there you go, we've got a grid. I'm going to make that a little more coarse, and that's just going to make the calculation a little bit quicker. It's preset to CBDM defaults, but you can change that. Okay, don't need to see the floor. Final stage. Let's run the calc. Lots of options here. If you see the dash, it means I've already put in a default for you, and 90% of the time, that's the option you would need anyway. So there's no need to. So you can change it if you want, but there's no need to waste your time. Now I'm just diving for a weather file. So climate-based, if you're not familiar, climate-based daylight modeling is based on actual sort of location-specific weather data. So I didn't even look at what that was. I think it's London. So yeah, there you go. Notice I don't know why that appeared. Some of these are sort of 20% of the time I'm using the actual native Dynamo sort of functions, but it's very light, and you'd pick these up very fast. Okay, I'm going to start the calc. I'm going to run draft calc mode so we don't have to sort of waste time while this runs. It's starting the calculation there. It's calculating daylight, sunlight. There's the director file. Can also calculate daylight factor. You need it for BREEAM sometimes. It'll do that for you. But if you're only interested in daylight factor, I would advise you just to go to Relux. Just a different program, and it'll be an easier way to do it for you. That's just finishing up. Well, I thought it was finishing anyway. Come on, get a move on. Do pass the time. Oh, there we go. Right. Okay, so basically we've done the calcs, and what it's done is calculate the illuminance value of every single one of these points for every single hour of the year. That's all best part of 9,000 hours over all those points. I don't want to see those. I'm sure you don't want to see those. So let's take a look at let's compare it to the EFA spec. That's Education Skills Funding Authority. So what we need to do is just plug in that, run the node, and it will take that huge packet of data. Now it's just going to sort of reformat it and ask the question, how does it perform against that spec? Yeah, that's all works so well. And now we want to see the results. We can look at the results in Dynamo. We can export the results to Excel. So let's take a look at, I'm always a fan of useful daylight illuminance. So we just have to plug a few more bits of these elements in here, just so it's all the way back here. Dynamo model, material specification. Right, we've got a full house. Restaurant default. There's a few. In fact, you know what I'm going to do? I will say, in actual fact, I do want to see the model outline, and right, go return me those results. So what it's going to do now is give me so here's the calculated results of that for a useful daylight illuminance. So what it's saying here is for 80% on this point, for 80.7% of the occupied year is 8 till 4. The illuminance is between 100 and 3,000 lux. It's a typical climate-based daylight modeling metric, and up here it's basically pass or fail. This is color coded, so the worse it gets, the redder it gets. Here it's like yes, no. Yes, it passes. No, it does not pass. So you can very quickly see the pass failure points. If you want to see all the results at the same time, you can use the native Dynamo list function, and you can say just give me the works, give me everything. I'm going to switch that to false now, actually, because yep, and we'll just run that through. So now we're going to see basically these are all the metrics that the ESFA asks you for, and there we go. So I turned off the pressing the wrong button. Yep. So I've turned off the show me the outline. It's still showing the windows. You can turn it off if you want, but it's useful if you just want to know, just for context, where were the windows in this model file. So we've got the excessively bright, underlit, within the useful range, and the daylight autonomy, and that's a full house for what you need for daylight for the EFA. And here's the model with the grid points for reference. Obviously, you can't give that to a client, or you can, but they wouldn't be very impressed. So here we got results in Excel. So then all we do is say, right, give me that calculation parameters. This is calculation parameters is basically it's showing you the calculation specification, your reflectances, the accuracy of your calculation. So we can sort of prove to our clients that we've done some due diligence, and if you do have a problem, you have a record of what you calculated. Material specs. I think that's everything. Shouldn't actually be doing that. Run those sets of files. Well, why do you keep trying to run it? Run the node. Like I say, you can. There are other options here. They're all on they're all on default. Yeah, you could add your own comments if there was something you felt you needed to add to this output file. Opens it up at the end, and yeah, here we go. Recovery file. Yes, I crash Excel a lot. Right, and it's exactly the same information. Like I say, here's the summary data. That means something to me. There's bits and pieces here. It's just, you know, we calculated in London. We bounced like 3 times. It was a draft calc. Don't go submitting that as a final submission. Oh, 5 minutes are up. And calculated bits and pieces. And here's the daylight autonomy. Exactly the same information we saw in Dialux again and again. Minimum target specification. So we wanted less than 20%. None of it is less than 20%. So we got ourselves a good result there. So I think I've probably ran to 10 minutes there, but that is a very quick overview of climate CBDM tools. I'll make some future videos. I'm going to go into detail, and from those you will be able to use the tool. So don't freak out if it didn't all make 100% sense to you. In future ones, it can get you started and run you through. Thank you very much, and I will see you in the next video.